Hi, good day to you and welcome to my channel where I tutor you in science for free. The topic in this video will be turning effect of forces. By now I think you already have played the seesaw before at the playground or opened a tin with a simple tool like a spoon. So all this employ the concepts that we're going to cover in this video. So firstly, we're going to look at this little vocabulary called a moment. And moment is not the small value of time that we are talking about here. It is the product of the force and the perpendicular distance from the pivot to the line of action of the force. So that sounds very complicated. So let's see what it is all about. So let's say if you push a door open further away from the hinge, you use less force to create an effect. But if you are pushing the door very near to the hinge, you are going to use a larger force to create the same effect because it obeys this principle, moment of a force equals to force times distance. And note that the distance must be perpendicular distance and the SI unit will be Newton meter. And this direction can be clockwise or anti-clockwise. So for example, you are sitting at the seesaw. If your direction is the clockwise direction to the pivot, your friend on the other end will be the anti-clockwise direction to the pivot. And so I believe while playing the seesaw, you would have tried to balance yourself. This is exercising the principle of moments. The principle of moments states that when a body is in equilibrium, the sum of clockwise moments and the anti-clockwise moments about the same pivot is the same. So sometimes taking into account differences in weight, you shift yourself towards or away from the hinge and you can achieve the balance. Sometimes this is also played in adventure camps. So there are two conditions for equilibrium. One is that this resultant moment must be zero and also the resultant force must be zero, which means to say that the upward force and the downward force should all be equal in order for all objects to not be moving. And so next we go on to center of gravity. So we want to balance something, we usually hold the item on the middle because that is the place where gravity seems to act on. If we support that point, then the object will be balanced. So usually in objects, the center of gravity will be in the center of the object. Of a uniform card or a box or a ball, it is usually in the middle. So sometimes it is in the middle, it is like in the air, for example a ring. And this simple exercise to find center of gravity will be like that. To find the center of gravity of the irregularly shaped card, you create 3 holes far away from each other as far as possible. Then suspend them using the retort stand and place a heavy object like pendulum bob suspended and just let it hang. And the center of gravity will always be under the pivot because that is where the point where gravity seems to act on, it's pulling it downwards, so it will be always below the pivot. So do the same for the other 2 holes and you will be able to find the center of gravity. So next we go on to stability. You realize that if you place a book flat on the table, it is a lot more stable than if you make it stand because the center of gravity is lower and the base area occupied is larger. So this stability is a measure of the ability to return to its original position after being tilted slightly. And in order for it to come back to its original position, the center of gravity must stay within its base area. So if you think about it, if it is tilted a little bit, then the gravity will pull it down back again. If it is under its base area, it will be locked back into position. So a general rule of thumb is if the center of gravity is being raised, it is said to be of stable equilibrium. If it is unstable equilibrium, then the center of gravity tends to get lower and the center of gravity easily gets out of the base area, and once the gravity acts on it, then it will drop. And if it is at a neutral equilibrium, then the center of gravity remains at the same height. So that's why cars, they have wheels like pretty far apart, occupying almost the whole base of the car to give it a large base area. Okay, let's go on to some sample questions. A lamina, which is a card or flat surface, it's suspended at point P. The weight is 2 Newton, center of gravity at C, and these are the dimensions given. What is the moment about P? The answer would be this, because you have to find force times perpendicular distance, not just any distance, so it has to be perpendicular, and we have to use this value instead. So you multiply by the 2 Newton, you get 0.6 Newton meter clockwise. Okay, this question, horizontal pole attached to the wall there is a pivot, the chain is connected, there is a tension, force F on the chain. What's the moment of the force F about the pivot P? It will be this times this, because it's force times perpendicular distance. So if you see things not as commonplace like the seesaw example, then where the angles are tilted in an odd direction, you need to extrapolate, means you stretch it out, or interpolate, retract it backwards to find the perpendicular distance. So this is the skill set to learn. Man is carrying a load looking like that. What is the upward force? Okay, so this tests you on the equilibrium principle. The total upward force must be equal to the downward force. So you need to find force F, so you can identify that that is the total amount of force pressing downwards. Then the shoulder has to give a equal and opposite reaction in order for it to not be moving, not have any resultant movement. So you have to add them all up. Okay, and we look at something a little bit more complicated. So this is a Chinook helicopter. Describe the difference between mass and weight. Okay, that's pretty simple. It will be this. If the weight is this, then the mass should be this. By taking moments about point X, calculate the lift force from the front rotor. So at point X is here at the back, and there's a force 150 k Newton going down at this point. I need to have the balancing force on the front rotor that goes upwards. This is how to calculate it. Force times distance, force times distance. This is the counterclockwise direction, this is the anti-clockwise direction. So when you talk about point X, you think about it as like a card, then you pin it on the wall free to move, and there's a downward force on the helicopter and on the helicopter card, and your finger has to push the front rotor upwards. Not sure if you're able to visualize that. Okay, and next, calculate the lift force from the back rotor. Because downward force is this amount, the upward force must be equal because it's stationary, so it's just simple arithmetic. So next question, pilot adjusts the forces. The front of the helicopter tilts down. So if the front is reduced, the back must be increased in order to maintain it not moving, because the total upward force must still reach this magnitude. This is to keep the center of gravity at the same position, at the same height. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!